So SN2 reaction with an iodine as a leaving group. We have a small reactive nucleophile, negative charge. The arrow should come from the back side. It's going to break the carbon-iodine bond. Leaving group leaves. SN2. The other big thing people forgot to do, they show this, but they wouldn't indicate it as being hatched, right? You got to show that. You got to show that inversion. A lot of folks also, somehow this carbon just left. It disappeared. It did not disappear. It is still there. Make sure you show it there. SN2 reactions, one step, no carbocations, no rearrangements, and inversion of stereochemistry if you have an asymmetric center. Those are the things to remember about SN2 reactions. So this reaction is a hydrohalogenation, which means we're adding an H and a halogen. It goes through a carbocation. That means you need to think about rearrangements. If we look at the starting material of the product, we see that something that we're adding doesn't end up on one of the original carbons of the pi bond. That should tell us rearrangements need to happen. A rearrangement is going to happen. So what's the first step going to be? Pi bond is the nucleophile. It's going to react with the HCl. Do we need to show that HCl bond breaking? Yes. So the pi bond reacts. Where should there be a carbocation? Which carbon? So if I draw in here, I should have made draw these hydrogens in. Always a good idea. Where is there a new hydrogen? 1. Very good. And the plus charge is on 2. 1, 2. Cl minus is floating around. What kind of carbocation do we have? We have a secondary. Can I make that more stable? Either through pi bond resonance or lone pair resonance, or a more stable tertiary carbocation. And I can do that by doing a hydride shift. There's an H right here. Those 2 electrons and the H go to carbon 2. That rearrangement so carbon 2 now has a new hydrogen bond. And the plus charge is now here, which leaves Cl minus available to react, and that gets us to our final product. So the last question on this was, did you make an asymmetric center in this product? So did you make something that's sp3 hybridized bonded to 4 different things? You did, yes. Chlorine, methyl, ethyl, terbutyl. So you did make an asymmetric center, yes. So that means, right, you made a pair of enantiomers. Right, you could say you made this and it's an enantiomer. Right, plus En. Right? Because you went through a carbocation, chlorine can come from the top or the bottom. The chlorine can be wedged or hatched. That's how you make both that's how you make enantiomers.